When we look at the Indian subcontinent today, it feels impossibly permanent. The staggering heights of the Himalayas, the vast Deccan Plateau, and the dense river valleys seem like fixed pillars of human civilization that have simply always been there. But if you rewind the clock roughly 550 million years, you find a massive anomaly. India was nowhere near Asia. It was locked deep in the southern hemisphere, fused together with modern-day Australia, Africa, Antarctica, and South America into a single colossal supercontinent called Gondwana. The name Gondwana actually comes from India itself. When 19th-century geologists were studying ancient rock formations in central India, they named them after the local Gond tribe, who had lived among those exact hills and forests for generations. To understand how those rocks got there, and how the modern Indian landscape was actually forged, we have to track a 9,000-kilometer continental migration, a journey that stands as one of the fastest and most expansive tectonic shifts in Earth's history. The journey began 180 million years ago, driven by intense heat deep underground. A massive ocean of magma began welling up toward the surface, creating immense pressure underneath Gondwana until it fractured the crust. The supercontinent broke apart. India began its northward drift, still physically connected to Madagascar, Antarctica, and Australia. About 150 million years ago, over the Mascarene Plateau, another massive volcanic eruption breached the surface, forcing Madagascar and India in opposite directions. That specific separation left behind an enormous physical legacy. As the lava reached the surface and cooled, it stacked up layer by layer, building the towering mountain walls of the Western Ghats. This event caused the entire Indian plate to tilt eastward. Because of that structural slant, almost all of southern India's major rivers were forced to change their course, flowing west to east straight into the Bay of Bengal. As the timeline moves forward to about 80 million years ago, tectonic forces finally separated Australia from the Indian plate, sending it on its own path toward the east. This data visualization shows the physical evidence for that ancient connection. If you analyze the rock strata and the magnetic alignment of the eastern Ghats in India and compare them to the mountains in Western Australia, they are a flawless match. With Australia gone, India became a massive island. It was now traveling alone across the ancient Tethys Ocean toward the equator. The proof of this ancient union is held in the rock. Mountains in modern Australia share the exact same composition as the Eastern Ghats, preserving a physical record of their continuous range. By geological standards, the Indian plate was moving at a remarkable pace. It was traveling northward at a rate of 15 to 25 centimeters every single year, several times faster than most tectonic plates. Roughly 60 million years ago, this plate passed directly over the Reunion hotspot. Constant flows of lava flooded the surface, eventually cooling into the colossal volcanic plateau known as the Deccan Traps. This period of intense volcanic activity occurred at roughly the same time as the Chicxulub asteroid impact in Mexico, roughly 66 million years ago. Between the asteroid impact and the massive eruptions in India, the global environment shifted. It spelled the end for the dinosaurs, including massive native species like the Rajasaurus that once lived in the Narmada Valley. Today, millions live and farm on the Deccan Traps, where the soil and landscape were born from this period of global mass extinction. 50 million years ago, the 9,000-kilometer journey reached its conclusion. The Indian plate reached the massive Eurasian plate, and the edges of both land masses began to buckle and compress. This collision was so powerful that it pushed the ancient ocean floor into the sky, creating the 2,400-kilometer-long Himalayan range, the tallest mountains on Earth. These geological features now dictate the rhythm of modern life. The Western Ghats act as a giant wall. When moist winds blow from the Arabian Sea, they hit these mountains and are forced upward, cooling to create the intense monsoon rains that sustain southern India. Further north, the Himalayas reach so high they capture millions of tons of snow and ice, forming the largest glacier networks outside the polar regions. As these glaciers melt, they provide a steady flow of water to the valleys below, feeding the Ganga, the Yamuna, and the Brahmaputra. India is the result of a 200-million-year voyage. Its geography, its weather, and its civilization are the direct consequences of a shifting planet that carved a path from the southern hemisphere to the top of the world.